mobility. I'm Daniel Wask, and guidance and help assistance in mobility workshop. Good afternoon. Now you can hear me. And welcome to the workshop and guidance and assistance in mobility and transport. We're going to begin with the session, which will last about an hour. I'm Daniel Wask. I'm a member of the Scientific Committee of FROL. I'm a professor of the Polytechnic University of Catalonia and director of the Chair of Accessibility. And I have the privilege of being with colleagues who are experts in this area of assistance. This afternoon we're going to listen to the presentations, each one which will last about 15 minutes, and we'll leave the last 15 minutes to answer the questions you may have, to broaden the subjects that are covered during the three presentations. In the first place, the first presentation will be CIT Solutions for Parking and Transport, the SIMON project, and will be given by Mr. Alberto Ferreras. Thank you very much. Whenever you like, you have the floor. Thank you very much. First of all, I want to thank the ONCE Foundation and the organization, the FERROL organization, for giving us the possibility to participate in this convention. I'm Alberto Ferreras from the Biomechanic Institute of Valencia, and I'm going to explain a project that we are currently carrying out, which is called SIMON. The purpose of which is to integrate different services, some that are already exist and others that are new, to facilitate different transportation activities in the city, and also for parking, transport and parking. This project came about because we realized there are a series of problems in the institutions, and we heard from associations and social entities regarding the lack of information and resources regarding options and alternatives to move around the city, both in public transport as well as in private transport for people with limited mobility, and reserved parking spaces and the non-authorized use of these parking spaces. Many times we found, or many times we see when we go to the shopping mall, that the parking space reserved for people with disability has been taken by other people or by another car that doesn't have authorization to park there. In general, another problem we've seen was detected by the European Commission, who finances this project and which is very interested in this, and also by the different city councils making up the consortium, is the fraud in the use of the European parking authorization, both the falsification as well as the non-authorized use of these cards, which harms the people who truly have the right to park in reserved spaces. Or here in Madrid, a person with this card can park in any parking space, for instance, the paid parking, without having to pay. So in the last years, this has given rise to quite a bit of fraud, and also the lack of incorporation of technological solutions, which many of them already exist, to provide services which facilitate both the transportation as well as mobility and parking. So based on these concerns, the SIMON project was born. It's a European project. It began in 2014, and its purpose is to start 3 big pilot projects in Madrid, here, in Lisbon, and in the Italian city of Parma. The purpose to facilitate transport for people with problems in mobility, different types of transport, subway, bus, roads, pedestrian sidewalks, people with private cars, for all these sorts of transportation as well as parking. So we want to integrate different technologies. Many of them already exist, such as the parking meters and intelligent phones, smartphones, and others which are being developed with different applications to facilitate the access to the information and to manage the rights of access. The consortium, which we belong to, is connected to the RT company, and they also were is participated in by the Biomechanic Institute of Valencia. That's dealing with these issues, the requirements of users, the requirements of applications, and the German country Coastlog as a technological developer. And we also, as I mentioned, are working in these three cities, the city of Madrid, and the Consortium of Transport of Madrid, the company that manages all the parking in Lisbon and transport, and the same in Parma in Italy. We also have users in Spain made up of Thermi, the state committee of people with disability, and other institutions which are supporting everything having to do with these pilot projects. The development of the project starts with the preparation phase where we talk about the requirements of the users, the different applications, different problems that the people with disability will have when they try and move around the city, and initial development of the technology. And we did a pilot project in these three cities. At this time, we are in the demonstration phase, the testing phase. What is it that we have developed? Well, the ICT things we've done is a new card for parking, the typical card for parking, which includes technologies such as NGC or URL codes, so that we can interact with different urban elements and personal elements such as the cell phones or parking meters, and mobile applications such as the parking controllers as well as the users to facilitate navigation, the validation, and access. The adaptation of intelligent parking meters to facilitate the validation of users who perhaps don't have access to modern mobile technology, but just have a regular phone, and access to databases of the cities, which allows so that the applications that we're using have access to the big data to allow for the design of routes, transportation routes, using different sorts of transport, or locating the user or to access restricted areas, or to validate the user in parking lots. And also so that the city councils can manage all this information. The applications which we developed are the Simon Leads, or the mobile, Simon Mobile, I don't know what exactly we're going to call it yet, but it's going to be available in Google Play within a few weeks. And it's aimed at users with reduced disabilities in movement. It'll help them to find reserved parking, identify the places where there's difficult access. It'll be able to identify routes for pedestrians, people in a wheelchair or a car using public transport, and above all, what it will do will facilitate the validation when a person arrives at parks in a reserved space. It'll read the card, and with a mobile application, you can see here, it will. You can move your cell phone next to this device, and it tell you what sort of parking space it is. It will answer, and then the system will validate that you have parked there, verify that you have parked there. In this way, the parking controller can verify that a car is correctly parked, and verify if the card is valid and if the person parked correctly. And then in this way, avoid and prevent fraud. That's the reasoning behind this application. The other application is Simon Controls, which is aimed at the parking controllers, and it'll allow them to verify that cars are correctly parked and to report incidents, for instance, or problems. For instance, if a car is poorly parked or the cars are parked in the nearby areas, are taking up space in their reserved areas, etc. These are the two ways. On the one hand, the user will be able to check into a parking lot and access restricted areas following the same procedure. The program has the option to access these restricted areas, for instance, in Madrid, their area.
And hopefully in the future we will see new projects. We've heard about a product that is going to be launched by Google that is going to change things a lot. We've done a prototype with a camera and a laptop. It's just a concept test with new algorithms, but we're going to see these type of things on a specialized mobiles.
Parece que ya volvemos a estar online, con lo que de nuevo la palabra.
Muy bien, muchas gracias.
Continúo con el tiempo.
Bueno, en primer lugar lo que hicimos en
First of
nuestro
all,
proyecto
we did in our
fue
project
estudiar un
was
poco
to
cuál es el
study
estado del arte en los sistemas
the
de
state of the
localización.
art in location
Todos
systems.
utilizamos ya de manera
We all
habitual el
use
GPS,
regularly
tanto
GPSs.
los navegadores que llevan los vehículos como los smartphones
GPS
llevan
on
incluidos estos
cars as
sistemas
well as with the smartphones
que tienen una
that
serie de
use the
características,
GPS
dan una buena
systems,
cobertura en espacios
have
exteriores,
serious
pero en
characteristics,
ocasiones
good
hay
coverage in
fallos de
outdoors,
precisión en tanto la
but
altura
sometimes
como en
we
la
have some
ubicación, y sabemos
accuracy
que eso en la
problems
medida
that
que
cause
entramos pues, en los
problems.
túneles de la
For
M30
example, when we get
o
into
por
a
determinadas
tunnel
zonas
in
en los que
areas
la
that are
cobertura
covered,
no llega a ver los satélites, pues no son capaces de
we cannot
posicionarnos
connect with the
correctamente.
satellites and therefore they
Este
cannot
problema se
position
agrava
data
además en los
correctly.
edificios,
This
generalmente o
problem
estamos muy cerca de una
worsens
ventana
in
y en
some
condiciones
buildings
idóneas, o dentro de los edificios
or
el
either very
GPS
close to
simplemente no
a window
funciona.
and
El
therefore the
hormigón actúa
conditions
como
or the
una pared
GPS
que
doesn't
evita
work.
ese acceso directo a los
Concrete
satélites y
prevents
sencillamente
direct access
no
to
pueden
the
funcionar.
satellites and therefore they cannot work.
Adicionalmente, todos
Additionally,
habréis detectado que cuando ponéis el GPS en el móvil la batería dura nada, absolutamente nada. Con lo cual, pensando en soluciones que realmente se puedan utilizar de manera extendida, el GPS tiene bastantes limitaciones. A pesar de que hay sistemas como el SBAS que permitió mejorar esa precisión, es difícilmente salvable el que un GPS funcione correctamente dentro de un edificio. Sí que es cierto que es un sistema extremadamente útil y extendido para los sistemas outdoor, fuera de los edificios. A continuación estudiamos pues, todas las tecnologías que hoy en día los smartphones nos permiten para conectar dispositivos. Por supuesto, estuvimos trabajando con Wi-Fi, estuvimos trabajando con infrared. Hoy en día ya los portátiles no lo llevan, pero si alguno de vosotros en su día tenía una PAL, las PAL precisamente sincronizaban con los ordenadores a través de un sistema de infrarrojos, de línea RDE. Estuvimos también valorando las tags de radiofrecuencia, todo el sistema RFID, que bueno, tiene un futuro muy prometedor, pero ahora explicaremos el por qué no era suficiente para lo que nos interesaba a nosotros. Evaluamos también el Zigbee, Bluetooth y por supuesto estuvimos viendo a ver cómo podíamos mejorar ese sistema GPS y utilizarlo dentro de los edificios. Al final, después de evaluar todo y de ver realmente los edificios de concurrencia pública que suelen tener, pues optamos mayoritariamente por utilizar Wi-Fi con unas palizas, unos beacons que hoy en día están también empleándose con bastante éxito, que son dispositivos Bluetooth que consumen poca energía. En definitiva, lo que pretendíamos era crear un sistema que la literatura lo llama localización basada en servicios, en base a
location-based in services using a GIS and a space database in which all of the areas within a building are mapped Also, we're using an internet connection. Also, we're using new information and communication technologies, and we're doing this with a mobile device that it is easy to use and friendly, user friendly.
lo que convenimos en llamar prototipo ISMO, de Indoors Mobile Orientation.
Then we
Lo primero que
created
tuvimos que
an
hacer
indoors
fue
mobile
verificar si
orientation
existían
system.
librerías, si existía
First,
algún
we saw
tipo
in the
ya,
market if there
algo
were
ya
any
avanzado en
libraries,
esta
anything that
línea
was
y
advanced in
sí que
this field
había
of
cosas.
action, and there
Había
were
una
certain
librería
things.
de una empresa llamada
There
Wi-Fi
was a
Slam
library in
que
a
lo estuvimos
company called
testeando y
Wi-Fi
realmente
Slam
funcionaba
that we were
bastante bien.
testing, and
Curiosamente
it
esta
was
empresa
working
fue
fairly
comprada
good.
por Apple
This
y
company
cuando
was
teníamos el proyecto
purchased
anunciado
by
nos quedamos
Apple,
colgados,
and when the
que un día de repente
project was
el auge
developing,
del
we
proyecto y ya no existía, no funcionaba.
unfortunately couldn't
Seguimos
progress
evaluando
anymore. The
diferentes opciones
project
y al
had
final
been
optamos por
deleted
una
and shut
librería de una
down. We
empresa
continue on
austríaca que
evaluating
tenía desarrollada una
options, and
parte
we
de los
decided to
módulos.
use a
Tenía una
library
precisión
by an
aceptable,
Austrian
un buen soporte
company that
técnico,
was
que en estos
fairly
tipos de
accurate
proyectos de
with good
innovación son
technical
fundamentales,
support.
y
Technical
tenía
support
un
is very important
prototipo
for
para
this
cálculo
technical
de rutas que
project, and it had a
inmediatamente
prototype
incorporamos
for route
en nuestro producto.
calculation that we
Aparte,
immediately incorporated in
tenía
our
la
project.
intención de ir incorporando todas las nuevas tecnologías que
We
pudieran ayudar
also
para ir
started using all
complementando y
new
haciendo más
technologies
potente
that could be
ese sistema.
helpful and that could
Lo que
make
a
this
nuestra
system
parte
more
era
powerful.
esa utilidad que ya existía, que estaba en el mercado, adaptarla
So,
para que personas con
a
diversidad
certain
funcional
utility that
pudieran
was already
utilizar
available on the
esta
market was
herramienta creada
adapted
por
with
nosotros
so
para
that
guiarse
people with
dentro de los edificios.
functional disabilities could use it
La
to
manera de
move around
trabajar, la manera
buildings.
que hubo que llevar adelante este proyecto, pues
The
tiene
way,
unas
the way
características
we did this
que
project
quiero resaltar. En concreto,
has certain
el trabajo
features that I would like to
consistía en hacer
highlight.
lo que se llama fingerprinting, que es
First of all, we
el
have to do
circular
some
por todo el
fingerprinting.
edificio. Ahí creo que soy yo con un ordenador y una serie de
Going
antenas,
around the
y lo que se
building,
hace
I
es
think
ir
you can see
captando
me in the
las diferentes
picture
señales
with
de
the computer, the
dispositivos,
laptop,
sobre
and
todo
some
de puntos de
antennas,
acceso
and
wifi
we
que hay
uh,
dentro del edificio.
first of all
Se va
map all
captando,
the
se va almacenando
Wi-Fi
en una base de
access
datos
points
y
within the
se va
building. We knew
identificando
where they
esas
were.
señales
We
que se perciben
entered
en
this
qué
information
punto
on a
en concreto
database,
del
and
espacio
we
en este
mapped
caso era
all of the
farmacia de
Wi-Fi
psicología, se
signals in
encuentran
this building.
recibidas
In
esas
this case,
señales.
it was the
Una vez se han tomado
psychology
todas esas
building of the
señales,
University of
hay
Madrid.
lo que se llama un análisis de escenas en base a
We've
algoritmos
seen an
carísimos,
scene
por el
analysis
cual
based on very
yo
expensive,
tengo
expensive
conocimiento de lo que debe de
algorithms.
haber en cada sitio
So I
de
know
la planta
what's
y
supposed to
la
be
aplicación en
everywhere
un momento dado
within the
cuando
building,
activa
and
todos
the
sus sensores
application, when we
trata de
activate all of the
determinar en función de
sensors,
la señal que está
tries to
recibiendo,
determine,
trata
depending on
de
the signal
determinar la
that it is
ubicación de donde
receiving,
se
the
encuentra. Entonces,
location
este es el
that you're
sistema que
in.
utilizamos
So that's the
en
system
nuestra
that
aplicación.
we are using in our
A partir
application.
de ahí, creamos un software para Android
Based on
inicialmente,
that, we
y el
created a software
funcionamiento
for
para el usuario
Android
relativamente
initially
sencillo.
that
Al
is
arrancar la
very
aplicación,
user-friendly. When
descarga
you
de
turn
ese
on the
servidor donde está
application, you
ubicada toda la
download from
cartografía
the
con
server
todas las
with the
señales
map
de
and the Wi-Fi
wifi con
signals.
esa escena en concreto que previamente hemos mapeado, la descarga,
Then
utiliza
this
los
is
sensores del
downloaded. It
dispositivo
uses the
para
sensors of
comparar
the device to
lo que está
compare
detectando con esa
what
base
they
de
are
datos
detecting
y
versus the
comparando con la base de datos
database.
establece la
And
ubicación
with this
de donde
comparison
ese
with the
smartphone se
database,
encuentra
we
en
know
este
the
momento.
location of that
Una vez que está
smartphone at
ubicado,
that
se
precise
puede
moment.
seleccionar de una
Once we know
lista
that
todos
location,
aquellos
we can
espacios que
choose
se han
from a
catalogado,
list all of the areas that
secretariado,
have been
secretariado,
cataloged.
hall,
I want to go
propiedades de
to
estos espacios, y
secretariat,
automáticamente el
I
sistema
want to
calcula una
go
ruta,
to
lo
the
vemos
hall, I
en
want to
el
go
mapa
to
más a la
room
derecha,
101 or whatever,
calcula una ruta
and we
y nos
calculate a
indica el
route,
camino que
we
tenemos que ir
calculate
para acceder a ese sitio.
how to go to that room
O bien
101.
una universidad para
I'm
ir
sure that this
a
has
tocar el
happened to
paso
us
de
at the
un
university to
profesor,
find the
o
office of a
un
certain
ministerio
professor,
para un
or at a
determinado
ministry to
despacho, que a
find
veces
a
es
specific
extremadamente
room that
complejo. La
sometimes is
aplicación lo
very
que hace
complicated.
es
So what this
precisamente guiarnos
application
dentro del
does is
edificio
to
para
guide
ir a
us
ese
inside
sitio.
the building so that we
A
can
partir de
get
ahí hicimos
to
una
whatever it
prueba
is that we want to go.
de usuario inicial con una
We did
persona
a test
ciega,
of
completo
a
con un
user test
flotectólogo,
with a blind
Miguel,
person.
en Valencia,
Miguel
es
was his
un
name.
experto de la
In
ONCE,
Valencia, he's an
y
expert
concluyó el
that
testeo
works
de la
with the
aplicación.
ONCE Foundation,
A
and
partir de
he did the
esas
first test
primeras
with the
pruebas,
applications.
pues llegamos a una
Based on the
serie de
first test,
conclusiones. Por
we reached
ejemplo,
a series of
la
conclusions.
cantidad
First of all, the number of access points to the Wi-Fi network in the building was not appropriate. There were some positioning failures. Also, we realized that we could do some improvements because these libraries use a navigation system that is not a compass, but it has to do with the movement, and therefore we had to include the use of a compass so that we could be well guided inside the building. We also created a system of improvements through a voice-over system. This was very useful for the blind users, and also we realized that the mapping that we did beforehand, well, is not taking into consideration some elements that can be misplaced, such as seats or chairs, or we have to verify that there is an area through which people can walk without finding any problem. We did some improvements. We made sure of loading the map in the software the moment that you got into the building so that the interface with the user was simpler. Also, the system was doing a calculation of the initial position, and from that moment onwards they established the route to the destination, but that was problematic because if the initial point was mistaken, then the whole route was mistaken. So now the system, what it's doing is to recalculate, as a GPS does in our car. We have to parameterize the timing because depending on the capacity of the phone, it went faster or slower. And also we send some sound messages so that it could be more user-friendly. The study that we did about the access points relocated the access points that were validated with heat maps. We also introduced a system of beacons with Bluetooth devices, low energy consumption devices that were not working really good where the power transformers were located. But after the improvements, we did an experiment with some of the final users that will be explained to you by my colleague Javier. Well, as my colleague was saying, once we implemented the system and once we verified the system with some experts, on the third stage, we tested it with users, real users. We included on the trial people with different type of disabilities with the help of some associations, and we asked the users to express what they were thinking, so they had to verbalize what they were feeling, what were they doing at all times. We got a sample of 10 users in between 22 and 42 years of age. Out of them, 7 were male and 3 were women, 1 with a visual impairment, 1 with a hearing impairment, 6 with motor impairments. One of them has several disabilities because that person suffered a stroke, and one of them was not disabled. Once we did the test with the 10 users, we passed them a survey with open and closed questions. We got together with the users, and the first thing that we did was to explain how the device was working and the system was working. We gave them an explanation of how the system operated and how the device was operating. We gave them the possibility of doing a free test, 5 minutes free test, so that they could get more familiar with the system and with the device. After these 5 minutes tests, we gave them 2 tasks. Each one of them divided into 3 subsubjects: choosing the building, choosing the route, and tracking the way. And they did it in 3 iterations, so that we will get the timing that it took them to do each one of the tasks. And finally, we gave them the survey. These are two graphs with the time that it took them to go around the building. We were measuring the navigation inside the building, choosing one building, choosing a route. And except for users 8 and 9, most of the users had a clear, good learning curve. And what happens with users 8 and 9 is because we put them under a extreme scenario because they did the test on the day before the holidays, so several access points were eliminated or closed or shut down, so therefore the signal was weak. In the other users, we can definitely see a good learning curve. There is another case of activity. In this case, in the graph, we see a good learning curve in all of the cases. Then we pass them the survey. I know that I have to hurry right now because I'm running out of time, but we did an analysis and 90% of the users thought that the application was good or very good. They were able to reach the place that they had to reach. They obtained their objectives. The majority of the people thought that the application was quite intuitive and they consider it useful. They even say that they wish they could use it on the real life and that they would recommend it to their colleagues. As a conclusion, we have developed a system, Indoors Mobile, that provides information about the location, uses maps for those people to move inside buildings using Wi-Fi technologies and beacon systems, low energy consuming beacons, and we did a final test. With regards to what will happen in the future is that we have to standardize all of the access points in public buildings, the height, distance between them, and a series of characteristics that we know but that we have no time to explain. Maybe later on in the Q&A session. Thank you very much for your presentation. It's been really interesting.
Continuamos ya con esta tercera y última presentación de esta mesa.
Third and last presentation.
Te paso ya
Pass you the floor.
Buenas tardes.
Good afternoon. As I mentioned before, I'm going to show you some experiments that we did to help move around inside buildings, supported by our GBD camera. We shouldn't emphasize the number of people with visual disability or with complete blindness. They use a cane to find obstacles and to move around. The freedom movement is essential. And here we focused mainly on the inside of buildings, which may be known or may be unknown. And we may have maps, but many times we don't have information about these spaces. As I said before, we've worked on robotics a lot, and guidance through computers, guiding wheelchairs independently, or carrying out actions, for example, in a factory. In this project, we launched an application, a personal assistance application, in order to develop algorithms to take advantage of the algorithms from robotics in these sort of applications. We also used a big, important development. Now many cameras and sensors are very accessible. They're low cost, and we can carry them with us. It's very easy. A camera is something that's very cheap. It's basically a piece of plastic with an electronic chip, and it's very cheap to manufacture. You need a computer behind it to take advantage of all of the enormous amount of information that it can gather, and there's a big scientific community which is developing this area, and we're surprised to see some of these products on the marketplace, but we'll be very surprised by many of the products that will be launched, because they'll be very robust. The information is very robust. So what sort of information are we gathering? Well, detecting doors, stairs, obstacles on the floor, where the floor is and where their obstacles are, or to read signs, something as simple as reading signs for people that have this disability. Aside from the normal cameras, in the last few years we've seen very low-cost cameras thanks to the big high consumption of video games, the RGB cameras, which have revolutionized robotics. These sensors, just a few years ago, cost thousands of euros, and now we can buy them just for 100 euros. Aside from the classic image, they give us information regarding the depth, infrared colors, and additional technology which will give us with a range of 3 to 4 meters. In infrared, this strengthens the algorithms to interpret the images, because now we not only have the image, but we can measure the depth. The problem is they don't work outdoors, because the infrared sensors don't work outdoors. We don't focus just on people with disability. Well, there are another series of applications or guidance. Here I wanted to mention the design of a prototype for a navigation assistant inside buildings using one of these cameras. These are RGB cameras, and a computer that's portable, a portable computer. We're trying to make the computer smaller now. And basically what we do is detect the floor, detect obstacles, and the system will alert us when there's obstacles, and also something to help us detect staircases and walk up and down staircases. In terms of, there's a question of how to carry the device, whether on our head or through glasses, and we ended up mounting it on the chest. This gives us is less complex, and it's very comfortable to use. The camera is pointed at the floor, so this avoids problems of privacy, which is an issue when we start to use cameras. The first thing we do is detect the floor, detect obstacles, using classic techniques to process the information. The floor is a flat surface, so we separate the floor, and from there we can detect what is above the floor. and we can use assumptions from the Manhattan world, things that we find inside buildings. The walls are vertical, the floors are horizontal. These sort of things make the system more robust. And in this case, we are able to segment and distinguish between this floor and obstacles. Another scientific contribution we've seen is to increase the depth range of these cameras. These cameras reach at about 3.5, 4 meters, depending on the light. And using, take advantage of the algorithms that process the images, we were able to increase the range of vision. With regard to detecting staircases, the algorithm helps us to detect the different levels. I don't want to go too much into detail, but the purpose was to distinguish the stairs. We looked at the building regulations determined to define what the stairs are, to distinguish a stair from a box that may be on the floor, for instance, which is an obstacle, instead of a staircase. And being able to classify or determine what a stair is, then we're able to detect the whole staircase. Sometimes we detect stairs, in other cases we detect staircases. So the process is repeated. We make system more robust to be able to detect the whole staircase. We've read a lot of, many of them only are capable to go up staircases, given the perspective of the camera. You're more difficult and more dangerous, because the perspective means that the last stairs aren't captured by the camera. Above all, for a system that has to capture this in 3D and measure the depth, compared to going up a staircase where the perspective is much easier to detect. Since we're at the university, to develop these algorithms, we need objective tests to measure the quality of the proposals and to compare our work with what's being done elsewhere. To test them objectively, we need data sets. And as we need to have controlled data, broad data, data that's been labeled manually with the reality to evaluate whether our system works well and how it works, its accuracy in percentage terms. So we compared our system to others, and this new sensor hadn't been used in robotics yet, but it's been used, but not portably. Robots tend to be more stable. The configuration, the configuration is more simple. What we were doing is more difficult because we were mobile camera sensors. Well, the classic approach to detecting the floor, I think when we say that we can say for 100% sure that the floor is the floor, but we lost part of areas, part of floors we weren't able to identify. Normally, there's a recall, a recall of 50%. We detected 50% of the floor. The other 50% of the floor escapes our view. In terms of combining the color image with a depth image, helped us to overcome this recall, and we could detect floor farther away, but we lost some of the precision. Generally, the vision in the computer many times is not as robust as we would like. if the light changes, if the sunlight comes through a window, it can affect the quality of the image. So but we reached precision levels of 99%. In terms of detecting staircases, we're very proud of our algorithm. With regard to the database that we've found in the academic literature, we had false negatives, 0 false negatives, and false positives of 0. In other words, we were accurate in everything. We didn't miss anything. This doesn't mean that our system always works. It simply means that we have exhausted the database that is being used by the scientific community to evaluate it. We, of course, found cases where it doesn't work, and what we did was broaden the database so that subsequent assessments can go further. In terms of detecting staircases, here we have a graph of the quality of the first stair is always detected, 100% detection, and as we get farther, move up or down the staircase, the percentage accuracy declines, above all when we're going down a staircase, which is the blue line, and in the 7th stair is very difficult to detect, even for a person without disability, because we're able to infer the stairs. Here are some examples. This system is based on structural information, maps, perpendicular right angles, and obstacles don't meet these requirements, and it's very easy to introduce a sensor that detects people. We developed this to detect people, and it actually was developed for video games. We developed a prototype for navigation systems to guide a person inside buildings, unknown areas, to detect obstacles and staircases based in RGB sensors, and it's been tested with good results. All this has been carried out in real time using a normal computer. This is part of a project. Well, there's more information available. There's publications and related work. And here I had a video, which I don't know if I have time to show you. Oh, we showed you a slide. The system has a auditive interface, audio interface, which is available. And basically, you have sound on the right and the left, depending on the distance. When we're closer, it gives us a sharper noise or a lower noise. And then with instructions in English with instructions, say you're close to an obstacle, this is a staircase, with a catalog of about 15-20 instructions, audio instructions. This isn't our strong point, and we didn't want to go beyond what was currently available. In terms of testing, we just performed the test with students, a couple of students who were willing to cover their eyes and walk around the university with this device, following the instructions of the device. Sechu tries to open the video. We can open the floor to questions, to answer questions, or listen to your comments. Yeah, you had a question? Thank you very much. I wanted to ask you, the system that you developed using Wi-Fi and Bluetooth, how do with Wi-Fi, there comes you have to adjust it to the network, and sometimes the configuration changes. Have you noticed that it works better for one system or the other, Bluetooth or Wi-Fi? Wouldn't it be better to use this Bluetooth? Above all, in a building that you have maps for, that you're familiar with. Well, our experience in the last slide, we showed how mentioned that what's essential is to standardize, depending on the equipment and the entry points. We notice that there's equipment that every X amount of time, in a random way, the channels change and the power changes. When you've done the fingerprinting with a certain mapping, and all of a sudden it changes, well, there's a lack of precision, or problems with precision, depending on the functional diversity. For a blind person, 5 meters is an unacceptable error, even though they're being guided correctly. Or this system says you have to go to the right or the left or go straight, but 5 meters isn't acceptable. But one of the things that we have to do well from the outset is standardize this entry through this channel. It issues this power, and it doesn't vary the positioning. The position doesn't vary based on the connection or the number of people using the network, so it doesn't interfere. But the cell phones and electronic devices does interfere, but doesn't cause as many problems as the change in the channels or the power, or this is up and running, this one doesn't work, that sort of thing. It poses a real problem. The problem with the Bluetooth and the beacons is that the distances aren't very big. The test we did with the iPhone after the 4S, they didn't work with the Wi-Fi. It had to be using the beacons. But they didn't work that well, and it wasn't cheap. It's not that expensive, but to set up the installation with the entry points, it can be used for other things, whereas these beacons only work for systems such as this. So based on our experience, a good network infrastructure, Wi-Fi infrastructure that takes account of these sort of applications to provide an additional service, which isn't just access to internet. That's our proposal. That's what we based a standardization in terms of the height, how they should be distributed among the different floors of the building. This isn't a panacea, but it helps us considerably. Complement this with QRL codes that as we've seen here in this building, or radio frequency tags, which, when you pass by them, help to calibrate the system. We think this is the ideal solution.
My question is for Albert, and I wanted to know how you manage the rights of what has been generated, industrial property rights. Do you consider to do a European patent? Who will be the developer? The Deutsche Technological Center, or which one will it be? The application. Well, we're not very concerned about the patent, because the property of the patent wouldn't be for the developer but for the consortium and the cities adopting this service. And this is a service that is going to be given for free within the cities. The problem is that we need a small period of time, so that if a city wants to adapt to this system, they have to synchronize the big data of the city, reserve parking lots, public parking services, etc., to the system, so that the system can read them and use them. But ownership is not for the developer, but for this association of cities. we're haven't done many developments. We're just integrating existing technology, and they have an open source code.
Muchas gracias a los cuatro ponentes de las tres ponencias.
Thank you very much to the four speakers. And I wanted to ask about the standardization. Have you considered any possible standardization in the use of this technology in the European parking car so that the same car will be valid to identify the user of the service and can be used with the technologies that you have developed? And to the second speaker, all of these indoors guiding technologies that require the installation of beacons, etc., they are only useful for the user who has the application or the service for which you have developed this technology. Have you considered the possibility of standardizing these indoors orientation technology so that if someone has a device compatible with this standard, every time they go to a new place, they can use this technology?
Bueno, en relación a lo que comentas, la respuesta es sí. Y además, de hecho, uno de los paquetes del último
The answer is yes.
precisamente el mapa de ruta.
In fact, we are doing a roadmap to be able to implement this at the European level. The Commission is very interesting, and the officer of the project tells us that their bosses insist on working with this because we want to facilitate roaming in the use of this European car. The European car has a European format, but it is managed differently in every different country. So the Commission wants to implement this type of technology in all the European Union following a mandate of the European Commission. They will give us some recommendations on the technical requirements for the design of this parking card so that it can be easily implemented in any city. With regards to your second question, for the moment, we are not aware of anything being done in standardization. In fact, the different companies working on this are hard competitors, and they are not ready to collaborate, but the mapping process of the fingerprinting, we know that Google has developed some experiments in airports and universities that are integrated within Google Maps. For example, you're driving and you're using Google Maps, you get inside a building and the mapping changes, but it's working. But this belongs to Google. Maybe Google in the future will end up giving license to use it. We wish this will happen because will be fantastic and we wouldn't have to differentiate these navigation application in between being indoors and outdoors. But also we need a database with the rooms for every professor, what every room is dedicated to, etc. To what extent do I want to share that information with Google so that Google can guide me to the room at the professor that I'm looking for? I guess this is very complex, but I'm hoping that we can come to an intermediate position so that Google decides to give for free part of their knowledge so that in combination with other technologies we can achieve a certain level of standardization. I hope I answer your question. I have a couple of questions now. You said your project want to propose a standardization of Wi-Fi access point, but I don't know if you just want to locate this Wi-Fi access point or to use the information provided by that Wi-Fi access code. You just have to locate the Wi-Fi access point, or you're going to use the information within it. Because in certain governmental offices you cannot get access to the Wi-Fi network to prevent hacking. My second question, the tariffs for using 3G, 4G is cheaper every day, so maybe I'm not interested in using the Wi-Fi connection. And if I don't want to use the Wi-Fi connection, how am I going to be positioned within the building? Is it worth to continue on developing something on that field, or maybe in 3 years' time, 4 years' time, Wi-Fi is totally obsolete and we're using a different technology? I don't know what will happen in 3 years' time. I wish I did. I will bet on the stock market if I knew. But Wi-Fi technology is just a replacement of the satellites. If satellites could operate inside buildings, we will not be needing Wi-Fi networks. The problem is that they don't work. And we have different possibilities. We can use Bluetooth beacons, QR codes. We can use radio frequency tags. There are many options. But the advantage in using Wi-Fi is that it has access points that identify them uniquely in the whole universe. The moment that I have 2 access points, I can do a triangulation of the signals and I can establish a position without mistake. That doesn't mean that I'm connected to that Wi-Fi network. I'm just saying that this point of access is, let's say, broadcasting around an area. The moment that I have several access, I can get to positionate a specific point with great deal of accuracy. So I do not need the connection or the data embedded in that connection, since I don't need to be connected, even if it's private or protected with a password. That wouldn't be a problem. Maybe in the future things will change, but we are still wiring buildings with RJ45, which sounds amazing, but they are being wired with RJ45. In fact, in some Spanish cities, they are implementing Wi-Fi to give coverage to all the citizens, public buses, trains, etc. Is this a safe bet? In technology, there are no safe bets. But from my point of view, it is a technology that gives us a very good performance, is also a very cheap investment. It allows us to give a better service to the people in that location, and that service can also be used for location systems. So I guess this is something that we will continue on using in the future. I would like to ask Josecho if it works. It works on the video. Maybe we can try and see the video. It's working on the computer, but it's not being displayed on the screen.
Available waist left and ahead. Step to the left. Oops. El audio sí que funciona.
Ah, vale, vale, sí.
The audio of the video is working, but that's just about
Entonces
it.
estaba comentando que lo que era la aplicación del sensor RGB había
You were
combinado
telling us
lo que
about
era
an
la
application and a
imagen
sensor
con la publicidad para poder
RGB,
mejorar las prestaciones.
and you were
¿Cómo
saying
ves
that
tú
you
poder
were
mejorar
trying to
todavía un poco más
improve the
tanto la velocidad
performance?
como el alcance de
How can you
los
improve the
dispositivos para
accuracy as
productos
well
más
as the
extendidos?
scope of the devices so that they
Bueno,
are
actualmente las técnicas, digamos,
more broadly used?
de construcción de modelos a partir de la imagen y de localización
Techniques to
El-
building
en el
models
vídeo
based on
académico se llaman de
image
SLAM.
location. They are
están
called
de
SLAM,
forma que una cámara la podemos estar moviendo
SLAM,
y de la
so
propia
that we
información de
can
las
move a
imágenes hayamos
camera.
sabido dónde está la cámara en cada momento
We know where the
independientemente
camera is
no
located
tener
at
mapa,
all
de no
times,
saber,
even if we
es decir,
don't have
la
a
cámara
map
va,
and if we do not know.
digamos, relacionando imágenes
anything.
con la cámara. El ordenador va relacionando
The
distintas
computer
imágenes tomadas desde
relays
distintos
different
puntos de vista
images
y
taken
acaba
from
construyendo
different
un
points
modelo
of view
3D y
and
localizándose
ends up
dentro de ese modelo.
building a 3D
Es
model
un
and
tipo de
locating
tecnología que se
itself
ha,
within
se ha
that
investigado
3D
mucho y que
model.
está alcanzando
This
niveles de
is a
madurez que yo creo
technology
que
that has
acabará
been broadly investigated,
quitando pues,
and I'm
pues,
sure that
este
it
tipo de
will
usos, estas
reach a
necesidades de
good level
localización.
of
Será la técnica
maturity
de localización en un entorno
so
desconocido
that we
en
will
unos
be able
años,
to
yo creo.
locate ourselves in
Porque,
an unknown
porque, bueno, los sistemas
environment.
empiezan a funcionar con garantías.
Because
Es algo
systems
hoy en día
are
muy
working
compleja, pero empiezan a funcionar
with
con
security,
garantías y no tienen ninguna necesidad de información a priori. Es
and
decir,
they don't
construyen
need
su
any
propio
a
mapa a la vez
priori information.
que se está tomando los datos.
They build a map as they
Los
take,
RGBD lo han,
the
lo han
information,
hecho
or they take
robusto
the data.
y bueno, pues
The
ahora se prevé también pues,
RGB
donde
are
lanzan
very
al mercado
robust.
también, bueno, pues Google en concreto tiene el
And
proyecto
Google
Talgo, en el que ya tiene el dispositivo, lo ha
has a
repartido
project,
unas
Talgo
cuantas universidades,
project.
principalmente americanas.
It has given
Se
the
está
device to
desarrollando
many
mucho
American
software y
universities.
creo
They
que
are
en breve
developing a lot of
lo sacarán
software,
al mercado con
and
ya
I'm sure
el
that it
software
will
de
be released
autolocalización
on
de
the
la cámara
market
y de construcción del
soon.
modelo pues con suficiente robustez para poder empezar a hacer pues, apps de posibles aplicaciones
And
como
I'm
puede ser
sure
Lidiado o cosas así.
new applications will come
Yo lo
afterwards.
veo factible en poco tiempo.
I think it's
Muy
feasible.
bien, pues solo me queda por mi parte agradecer a los ponentes y a los
I would like to
asistentes
finish
que
by
han participado en esta
thanking
mesa.
the
Para mí ha
speakers
sido
and the audience for participating in this roundtable. It's been a great pleasure to get in contact with you and getting to know these topics that you've presented to us.
Sentarte tranquilamente y conocer justamente estos proyectos interesantísimos y que
It's
nos
always
aportan y
interesting
se
to know
complementan
these interesting
y nos están, en
projects
el fondo, ayudando a todos
that help
a
us
tener
all
una tecnología más cercana al usuario.
to have a more user-friendly technology. Thank you.